kind of a complicated thing to visualize. So I can try to show this to you two different ways. One way to show it is surface versus shallow versus deep. So the shallow looks lighter in color on the surface, water's moving one way. At depth, the water's moving in the opposite way. If that visualization is complicated, you can try this one. Deeper and higher current. I can explain how that works simply by adding heat and cold to my model. Naomi, can you please bring me the tray of ice from the freezer?
Why does red sink faster?
No, I have no idea. Usually these mix a little faster. It's a little frustrating that they're not mixing better. Maybe I'll get a chopstick in there. Okay. Here, you can take a shot. Yeah. Actually, no, I'm sorry. Can I have one?
I think we were literally using just one pencil last year.
Yeah, now I'm done. On one side, you can see I'm adding ice cubes. On the other side, you can imagine where this is going. I'm going to add pretty hot water from our microwave.
Nice.
And on the left, just to make that cold get around better, I'm going to create an ice bath. I wasn't going to make a big old mess on my counter. Okay. Now, anybody know what's going to happen over here?
Red's going to cruise through the bottom. Top? It's cruising through the bottom.
Who's going to cruise where?
Red on the top.
Why?
It's hot, right?
Yeah. Dude.
No, it's hot.
I mean, well, if you look at it, blue started through the top and red started through the bottom, which is right.
That's a fluke.
I think it's going to stay how it is right now.
Let me show you something. I've added heat on this side and cold on that side. So here, you're heating and that water is going to rise and build a high pressure that expands. Here you're cooling, so that's sinking. So there's going to be a low pressure here and heat there. Just like this. It's no coincidence that I put it in the same place on the same sides. Soon, as the red water gets hotter, the heat will rise, and because all of those molecules are slamming into each other at the top of the red tube, they'll expand outward. The blue's getting colder, so all those molecules are slamming into each other at the bottom of the blue tube. So those will have a high pressure at the bottom, and the blue is starting to migrate. The red has a high pressure at the top, and so there goes the red beginning to migrate. In a few minutes, I will create lateral water currents by having made one side hot and one side cold. Soon you'll see red moving from your right to your left, and soon you'll see blue water moving from your left to your right. You may already see that. There goes the red, and there goes the blue. For those of you that have a little glare, good.
Nice.
Nice demo, right?
Yeah. Pretty cool.
Now, that happens in the ocean. ocean too. There are places where water is getting hotter and places where water is getting colder. The three parts of the ocean we're going to talk about a lot are North Atlantic, Indian, and North Pacific Oceans. You'll need to know that. And this is going to get really confusing. I scramble them all the time. I come from a country where we face the Atlantic Ocean, and now I live in a country where I face the Pacific Ocean, and so my brain is just mixed up, I guess. So I'm going to tangle them, but you need to know three different parts of the world, and I'll describe what happens in all three. North Atlantic, Indian, and North Pacific. I'm going to go back to this drawing, which I think makes it easier for me to do the first part. As you can see, in the North Pacific, remember, you got to know about all three of these. In the North Pacific, the wind comes out of the North Pole, creating upwelling off southern Alaska. You can see it right there. I'll use my screen to say that again. Wind comes out of Alaska, blows offshore, that creates upwelling here. Do we agree? Yes. I'm bringing cold water from the bottom of the ocean to the surface. That's like a refrigerator. It's an air conditioner. Bringing up cold water means that water is going to heat up, taking heat away from the Pacific. The North Pacific has an air conditioner. Upwelling brings cold water to the surface, that takes away the heat. Do we agree with what I just said? Yes. Are there questions about the North Pacific? No. Look at the Indian Ocean. Same thing. In the Indian Ocean, we've got the exact same phenomenon. You've got wind blowing offshore that creates upwelling. Because it's upwelling, cold water is surfaced, like a refrigerant. That cold water will heat up, robbing the Indian atmosphere of heat. It's an air conditioner. It takes heat away from the Indian Ocean. And you'll notice we've added more heat to the same current. By the way, look at how bold my colors have become. You can see the same current I'm describing at work right here. By adding heat in one place, or by cooling off the other place, we get lateral motion. But now let's talk about the North Atlantic. The North Atlantic is exceptional. The North Atlantic has, first of all, a polar current striking the westerlies, and so you get a lot of wind in the North Atlantic. The North Atlantic is very windy. Because it's very windy, water evaporates. And because water evaporates, that's taking heat from the ocean, parallel to the cell phone, taking heat from the ocean and putting it into the atmosphere. In the North Atlantic, we have a heater. Hot water is delivered, and evaporating it is heating the atmosphere. Does it make sense to everybody? Mm-hmm. We have wind on hot water making it colder in the North Atlantic. So that's heating the atmosphere, taking the heat out of the water, putting it in the air. Heater for Europe. By the way, look at the wind direction. So this water comes in hot, evaporates, and the westerlies blow that hot water vapor onto Europe and Russia. See what I did there? Hot surface water, when evaporates, that water vapor gets pushed by the westerlies into Europe and Russia. And if you don't believe me, give me another explanation why that is considered tundra, but that is considered grassland at the same latitude. Where we have tundra, they have corn belt.
Weird.
It is weird. Europe is about 10 degrees hotter than it's supposed to be in terms of latitude. I mean, Mongolia is at roughly the same latitude as Scotland. Yeah.
So in that, looks like in the Atlantic, the
Yeah.
warm water is going down. Is that what it's doing?
It is, because after the water has given away its heat, it is now colder and sinking. That's right. That water sinks faster than any other movement of water in the entire ocean. There's more water moving in the North Atlantic than anywhere else on Earth. It is 5 billion gallons per second sinking off the surface. It's not like a single point just like sucking boats down to Atlantis. That would be really cool. But I mean to say that the entire surface of the North Atlantic on net is sinking. Because it's given away its heat, so it's getting more dense and cold and lazy and dropping. Something else happens too. What happens when you evaporate water from the ocean? What's left? That's right. Now remember, it's called the thermohaline current for a reason. Thermohaline, because it's not just temperature, it's also salinity. That really cold water sinks because it's cold and more dense. And it also gets saltier, so it sinks even more. Thermohaline, driven by temperature and salinity. This explains the world we live in today. Actually, the world we lived in until about 15 years ago. For the last 15 years, something really unusual has changed. We believe this only happens once in the history of the current tectonic pattern. What would happen to that really salty water if we added a bunch of fresh water?
Get less salty.
It would get less salty. Does fresh water float or does fresh water sink?
Float.
Fresh water floats.
Yes.
So, by making the North Atlantic, the other one too, please. By making the North Atlantic less salty, we could stop this current, right?
Yeah.
Does that make sense? Because fresh water floats over salt. The salt is denser, the salt plus water, so it's everybody agrees with me? Now look, does anybody see any sources of fresh water in the North Atlantic?
Oh yeah, the Iceland or Greenland.
Yeah, you know Greenland, that giant glob of snow.
Yeah.
Which has melted faster in the last 15 years than ever in the known history of Greenland. As a matter of fact, Greenland has lost roughly a quarter of its ice volume to the Atlantic Ocean in the last 20 years. So, we've already seen this current begin to collapse. Here's a funny thing. If I could make this water fresher, that would force it to float. Despite the fact that its cold is trying to sink it, its freshness would float it. Does that make sense to everyone?
Mm-hmm.
So if I do the full demo, I have to put salt into this, and then while it's blending, I can add fresh, and that stops it. Technically, it's kind of hard. You have to make it super salty and have a lot of fresh, and that's not always doesn't always work. So I don't bother with that part. You'll have to use your imagination. But where the blue is moving because it's colder, I could get it to float by making it fresher, and then I could stop this current. So what would that do? What would happen if I took away this current up here? Anybody know what would happen?
Up there.
Yeah, what would happen here if I take away the current?
No more alcohol.
And so what would that do to the temperature of the North Pacific?
It would make it warmer.
It would make it warmer because we've lost the air conditioner, right?
Yeah.
Why right there?
Because here, cold water is being surfaced. That's this part on the right. And so if you stop that by no longer surfacing cold water, or by the water coming up